everyone. We have here some people from Streamr in the front, hi guys. Some people from Chainlink that I haven't met yet, but we can meet afterwards. You, some of your colleagues. Hi. So the plan is following. I'm going to present quickly Streamr, show quickly the integration with the Chainlink, and then maybe we can have a demo of our drag and drop editor to work with the data. So. Okay, so this speech is focused on smart city, but you can think about any other kind of IoT devices. You can apply it to anything. So if you think about smart city, you have lots of IoT devices that contain useful data. It's not only cars, it's also roadside units and others. And it would be great if they could collaborate, if they could talk to each other, exchange data, trade data with each other, utilize micropayments when trading the data. And this data could be used for many useful things, like to warn you of the collision ahead, to warn you of the changed road condition, to find you the best price of fuel or charging on your way. However, if you look on the reality of a current smart city, what you see are many IoT platforms that act as silos, and these are preventing devices from collaborating together. And these IoT platforms are typically based on proprietary solutions, where you often vendor lock in when you decide to work with one of these. And there is no open ecosystem where all these devices could exchange their data and where they could collaborate. And if we briefly look into the history, we can find a parallel with the beginning of internet. So back then you also had computers connected to intranets based on proprietary solutions, the same as the IoT platforms, and these intranets were not able to talk to each other. And what had happened, someone had to develop neutral protocols to connect all the computers into internet as we know it nowadays. So if we want to inspire ourselves here, and if we want to find a solution for the IoT city, the solution has to be open, it has to be permissionless, and it has to use neutral protocols and standards for the communication between the IoT devices in the smart city. And also, in addition, the successful solution has to make data globally available in an open and secure way. So the Streamr network is using cryptography instead of silo walls to keep the data safe. And the second aspect for the success is to enable data exchange or value exchange between devices. So you cannot do this, of course, with bank accounts because they are only for humans. So that's why IoT and blockchain, it's a great match. We can have data exchange, we can have a value exchange between devices in a form of cryptocurrency on the blockchain. Actually, this economical aspect is very important because it motivates the data owners to share the data they have from the devices in exchange for the money they receive. So the Streamr network, it's a decentralized peer-to-peer network. The model is publisher to subscriber. You can publish data to any topic. We call this streams. It's designed with a low latency in mind and scalability. You can scale it by adding new nodes. It's an open ecosystem. Anyone can run the node. And there is no central point of control or no central point of failure, which makes also the network less prone to cyber attacks. So if you think about this network, this could serve as a medium in a smart city where all the devices could exchange their data without any central party in the game. And the second part of the technology is the Streamr data marketplace. So any device can offer its data in the form of live data to be sold on the marketplace, and any other device can purchase this data. What is being purchased is always it's a time-based subscription. So you can buy a subscription to your stream for some time, 1 day, 1 hour, 1 week, and so on. And of course, the marketplace is decentralized. As you may know, it's running on Ethereum blockchain, and we use smart contracts to record the access rights and to record the settlement when the data is sold. So this is our recipe how we could improve the functionality of a smart city. And to showcase this, we've done recently a pilot in a Cross-Ethereum Alliance. It was with this nice Check Your Eye face, a company with Learn Code for providing hardware wallets for cars and also for other devices, and a Bosch that provides us access to the real-time in the car. And the pilot goes as following. So you had cars selling their data via the Streamr network. Some were equipped by the car OEM with the technology. Some have been retrofitted with a tablet or smartphone. And we've been sending the data to the Streamr network and offering them on a marketplace. And then you have different independent AI companies buying the raw data from the cars, so the raw data like speed, position, velocity, angle of the steering wheel, and so on. And these are processing the raw data and building their products on top of this data. So the problem that many companies have is they don't actually get the access to the data they need to develop their products, and it's like a closed loop. So if you have a good product, you have more customers. If you have more customers, you have more data, and then you can even improve your product furthermore. But you have to start somewhere. So we have different companies focusing on different fields, having different products, and they can resell the higher level data back on the marketplace, not only for cars to profit from it, but also for other devices like roadside units and dynamic speed sensors and so on. As you can see, what's interesting on this graph is that the backend part and the field part is overlapping, because this is not only you can have node runners running the node, but you can also place the Streamr network node directly into the car to support the network. So if you have spare resources in the car in terms of CPU power and in terms of connectivity, they don't have to go wasted. You can utilize and support the network, and eventually earn some money for running the node. This is the node we use, and this is the overview of the marketplace. So the Streamr stack, just to give you a quick overview, the main parts is the Streamr network and the data marketplace. What we'll see now from Runtime will be Streamr engine and editor. And this one's right here. That's it from me.
But basically, I'm going to demonstrate how to use Ethereum with Streamr. So I'll demonstrate two modules. Actually three. One for compiling Solidity code and deploying it. One for making Ethereum calls to compiled modules, and then a get events module, which is notified when specific events happen. And then so I'll show you how that works with the Streamr canvas. So for this example, I'm using the example of a stock ticker. So this is a simple Ethereum contract I have. So basically there's an owner, the guy who creates the contract. The owner can update the price, and then when you update the price, you should see a price updated event. And actually include the index symbol, the symbol twice here, because the index symbol would actually sort of a hash of the symbol if you do an index, so you won't actually see it on the output. So, but I have the Streamr canvas, so how do I get that with? So let's take a look at the canvas here. Tiny mouse cursor. Okay. So this is the module to do deploy code. So the way that works is you enter your code here. Let me move this one. So here, that price ticker that I had in VS Studio, that's the code for it. It's already been deployed, but I can redeploy it also. In which case, I'd have to change the inputs probably. I think all these connectors will disappear, so I'll save it for now. But it's been deployed on the Robston network, and you can choose which network you're using by looking at the options over here. I have to go stop there. So right now it's running. When you press stop, then it goes back into like edit mode. And so over here you see the options. You see that it's running on the Robston network. And I should say also, you set up your Ethereum accounts in your preferences. So this key over here is actually specified in the preferences section. So I'll go there. So basically, you give us your private keys. So it's not recommended that you store lots of ether on these keys, and that's the value of the keys. But you just copy and paste your private key here, and that's where that key in the previous canvas comes from. You can get it in the also. Make up a private key.
Well, I mean, as long as you have the same private key
Yeah. And one of the things that I set up for this demo is a stock ticker. So Streamr allows you to buy and sell stream data. So the way you set that up is also with this GUI. And in my case, I'm going to be taking the output. So in this demo, we'll be compiling code for the stock ticker, making an Ethereum function call with that module, and then listening to the output, and the output will actually be pumped to a Streamr stream. And so I've created a Streamr stream over here with a symbol, timestamp, and price in US dollars rate, for example. So that's where you set up your Streamr stream. So when we go back to the module here, this center stream over here, when you type in the stream name over here, it auto-completes and finds the stream with that name. So one called test stock ticker is the one that I selected. So I'll run. So just to go over all the different modules, this one does compile and deploy. Once it's been deployed as a contract output, the contract output is piped into both the Ethereum call, which tells it which contract to call, and this get events module. And once you give it the contract, then it automatically fills the event parameters in the ABI. And then for the Ethereum call module, you can call both static like view methods and transactional functions. You specify your Ethereum key if you're doing a transaction, and as inputs over here, I just have a constant input, which is the word Streamr or some fake stock ticker name. The clock over here actually outputs a timestamp every 5 seconds, but I've turned off the driving input. So driving input means that if it sends a new value, then it'll trigger the module that it's sending to. So in this case, I've turned off the driving input so that I want to drive it from this thing down here, and that's where I'll actually put in the price and weigh. So that's a button over here, and this is actually a driving input. So when I press the button, that should trigger this module, create an Ethereum transaction, and then this module, independently from this module, listens to new data from this contract. So if I press start, let's see what happens. Should be live. And so when I press this button now, that should actually trigger Ethereum transactions. These are transactions I've done in the past, but if I press this a few times, now with this this is the Etherscan for that account. And you see that we have 2 new transactions over here, 1 second ago. So that was, these transactions were just called by pressing that button. triggering the Ethereum call module. And hopefully when these transactions come back, we should see them in the get events module. I've seen there's some lag actually, so we're using Infura, and it's possible that there's some lag in between. We use WebSockets to receive the events, so it's possible there's some lag there. But eventually we should see the data in the output. So let's see, let's go back to the module here. Right, so when this completes, you should see output over here. And also you should see it piped to the center stream. So with inputs, you can only have one input, but the output can be piped to multiple modules here. So in this case, we're piping the output to a table, and we're also piping it to the center stream. I should warn you, I've seen missing events also. I'm still debugging this, but it may or may not come. I think it will, but it may take some time. There might be some lag in this. Maybe I'll do a refresh or something. That's okay, right? No, that was at 351, so I noticed that, but I've been noticing this before, that there's some either missing ticks sometimes, or sometimes like a bunch of them come at once. I'm still debugging this actually. I think it might be Zero that's actually not setting the date, but I noticed it the other day. But anyway, yeah, there it goes. Okay, so now it's coming through. So that might have gotten all the ones we were missing, so sometimes there's a bit of lag. So these are the transactions that were just triggered, and you can see that we actually decode the events as much as possible. So in the case of indexed event parameters, they're only posted as a bytes 32 hash. But so in the case of an index string, for example, you'll just see the hash of it. But because I'm posting the string twice, once is an index parameter and once is a non-index parameter, we see both over here. And then this is timestamp generated by the clock module, and the price that I put over here, the price that came from this over here. And then if you go to the stream that I was piping to, you should see the data there as well. So let's go check that. So I had to send the stream module, and then over here, if I look at the data, you see the new data points over here.
You can turn it like this so it doesn't cross-talk so much.
Yep. Hello? Hello? Yeah. So then you can see this is the actual stream data that is posted by that center stream module. And yeah, that's all I planned for today. I mean, there's a lot you can do with stream canvases, but I just wanted to give an overview of the Ethereum module. You can also call constant functions, of course. And if this canvas is running, also the get events module will, of course, be notified by WebSocket events when anyone calls an event in the contract. So you don't have to call the event in this contract in particular. It just monitors the contract for all the events. So, yeah. Any questions about yeah, that's how it works.